So module 4 is on graph theory. Graph theory originated more than 300 years ago, although it's used more now than it was back then. Back then it was more just a puzzle. Now it's exploded with the internet and with social media and how they advertise. Um, so now, and I'm sure you've noticed this, like if you talk about something or look like Google, like search something, a lot of times you'll end up with those types of ads on your feed, your social media feed, whether that's Instagram or Facebook or whatever. And so that goes into graph theory. They use graph theory a lot with that. They use it to plan flight routes. They use it to um, figure out how to deliver packages. So as Amazon has come on, they've figured out what's the shortest, quickest, easiest, cheapest way to deliver the packages around the world. And so first off, we're just going to talk about some vocab. The first thing is a graph. And so normally when we think of a graph, we think of like a coordinate plane, and we think about dots in that coordinate plane and connecting them and creating some type of function. In this case, when we look at graph theory, a graph really is just consists of dots and edges, and they connect each other and they form these vertices. So an edge is connected to a point, and that's called a vertex point. And so it's not a normal graph. This is called a mapping as well, but it's just connecting the points. And all four of, well, I should say three, all three of these connect the same number of points. It's just the way that they're showing the connection between the same vertices that changes. And so exactly the same points is just connected differently. So they're all equivalent since they use the same edge connections, but again, the path looks different or the mapping looks different. Some other things that we need to talk about is the vertex. A vertex is just a dot in the graph, and it can represent an intersection of streets. It could represent like the school or a house. It could represent the cost from it to go from one place to another, the distance it is from one spot to another, anything like that. So another vocab word is edges. The edges are just the segments that connect the vertices. So as you look at a mapping, an edge is just the line that connects two dots. The degree is the number of edges meeting at a specific vertex. It's possible for a vertex to have a degree 0 or larger. So if I just have a random dot somewhere, this would be a degree 1. But if I have a dot and I have 3 lines coming off of it, then this would be a degree 3. So this is a degree 0, this is a degree 3 because there's 3 lines coming off of it. 1 line coming off of it would be a degree 1. So that's what a degree is just how many lines are coming off of a specific point. A path is a sequence of vertices using the edges. Usually we're interested in a path between two vertices, so we want to know how do we get from one place to a next. But a path can do, like it can just be connecting all the dots, but not necessarily coming back to the beginning spot, where a circuit is a path that begins and ends at the same vertex. So a path could be you have 3 points here, and a path would be you're getting from, let's do it in a different color. It'd be like going from here and then to here. Okay, so a path to get from, let's say, your house to this school, and this is your friend's house. So you go from your house, you pick up your friend, and then you make it to school. That would be a path. Where a circuit would be you've got your house, your friend's house, and then school, And you do that. You go from the house to the friend's house. You go from your house to your friend's house, pick them up, go to school, and then after school, you guys go home. So that would be a circuit where you go all the way around. So you start and end at the same spot. Connected is a graph that has a path from any vertex to any other vertex. So this would be an example of connected, where a disconnected graph is where you have to lift your pencil to go from one path to another path, or from one dot to another dot. And the weight is the value assigned to an edge. So it could represent distance, cost, travel time, anything like that. So when I look at example 1 and they're talking about a degree, then I would say degree A, or point A, has a degree 1 because there's only one line coming off of it. Where B is a degree 3 because you have 3 lines coming, or it's a degree 4. Sorry about that. I can't count. Well, pretend this is a degree 4 because there's 4 lines coming off of it. C is a degree 2 because there's 2 lines coming off of it. D is a degree 3 because there's 3 lines coming off of it. And then E would be another degree 2 because there's 2 lines coming off of it. And so that's all you do with degrees. Connected and disconnected. What I talk about is like how you have to lift your pencil. So notice that I can go like this. I don't need to lift my pencil. So this would be an example of connected. But in order for me to go from this one over to the other one, I have to lift my pencil. So that's disconnected. So 3 connected, 4 disconnected, 5 would be an example of connected, and 6 would be an example of disconnected because you have to lift your pencil. They're not connected. So the graph, so that's just the degree and the connectedness. An example 3, it talks about the graph shown below, shows 5 cities, and the weight is the airfare cost to fly from one city to a next. So it says, well, how many vertices does the graph have? So the vertices are the corner or the cities that you're traveling to. So you've got 1, 2, 3, 4, and 5. So there's 5 vertices. And it says, well, how many edges is that? So that means we would connect all the edges. So when I'm connecting the edges, I have 1, I have 2, 3, 4. That wasn't very straight. 5, 6, 7, 8, 9, and 10. So it looks like we have 10 edges. And then it says, is the graph connected or disconnected? So hopefully we see that it's connected because we don't have to lift our pencil. And it said, what is the degree of the vertex representing LA? So we want to know how many lines are coming off of LA. So we've got 1, 2, 3, 4. So that makes LA have a degree 4. And then it says, if you fly from Seattle to Dallas to Atlanta, so think about what that is again. So we're flying from Seattle to Dallas, so here, and then from Dallas to Atlanta. Is that a path or a circuit? So that's a path because we just stay at Atlanta. It's like a one-way trip. We go from Seattle to Dallas to Atlanta, and then we stay there. Where if you were flying from, let's say LA, so we'll do this in orange. We're going LA to Chicago. So we're going this way, and Chicago to Dallas. And then from Dallas back to LA, because you made that full course, you ended where you started, then this would be an example of a circuit. And that's kind of where we start off. It's not horrible. Then we have Hamiltonian circuits and paths. A Hamiltonian circuit is a circuit that visits every vertex once with no repeats. So that's this red plan. That's not the only Hamiltonian circuit that you have. You could go the other way, but you just have to be able to visit every dot without repeating a dot. All right. So it must start and end at the same vertex, and it needs to visit every vertex once with no repeats. Okay, that's the big thing. A Hamiltonian path, though, visits every vertex once with no repeats, but does not have to start and end at the same vertex. So this little guy out here, E, it's fine. You can go from E to A to B to D. So you visit everybody, but you don't need to start and stop at the same place. I see if we have enough battery to finish this last problem. So it says, suppose a salesman needs to give sale pitches in 4 cities. He looks up the airfares between each city and he puts the cost in a graph. So this is my graph or my mapping. It says, in what order should he travel to visit each city once and then return home with the lowest cost? So he's starting at Seattle. So if he was going to start at Seattle, he would want to go to the cheapest spot because he wants to go cheap. And so the cheapest way would be to fly to LA for $70. So he's going to go Seattle to LA, and that's $70. And then from LA, I can go to Dallas, to Atlanta, or to Chicago, and it looks like it's cheaper to go to Chicago because that's $100. All right, and then from Chicago, he can either, because he needs to visit everybody, he can either go Atlanta or Dallas, and so Atlanta is cheaper, so he's going to go this way. All right, so he's going to go to Atlanta. And then from Atlanta, the only place he hasn't been yet is Dallas, and so he has to go there, which is 85. And then from Dallas, he's going to go back to Seattle. So if it asks you for the cheapest path,